Welcome back to another training session of the TAE certification series. We completed section 6.1 in our last session, and in today's session we will go through section 6.2, which is identify steps needed to implement automation within regression testing. Regression testing provides a great opportunity to use automation. First of all, let's see what is regression testing. When you add new features or make changes in the software, there is a chance that it might break other parts unintentionally. That is where regression testing comes in. It's like a safety net. It checks the entire application to make sure that the changes have not broken anything that was working fine before. Now, doing this manually can be very time consuming and quite repetitive as well. That's where automation steps in. Using automated tools for regression testing can save time. They can catch issues more efficiently and let manual testers focus on more creative or complex tasks instead of doing repetitive checks. It's a win-win situation. A regression test bed grows as today's functional tests become tomorrow's regression test. As new features are added to a software, the tests initially performed to check these features become the foundations for future testing. These original tests transition into regression test ensures that existing functionalities remain intact as the software expands. The tests that used to check the basics now protect the existing working parts from getting broken by the new changes. It is only a matter of time before the number of regression tests becomes greater than the time and resources available to a traditional manual test team. Tests are like tasks on a to-do list. At first, it's very easy to handle them manually, but as the list grows longer and longer, it eventually becomes too much for a traditional manual test team to complete within their available time and resources. When outlining steps for automating regression tests, several questions need to be addressed. And here are those questions. Number one, how frequently should the test be run? Number two, what is the execution time for each test for the regression suite? Number three, is there functional overlap between tests? 4, do tests share data? 5, are the tests dependent on each other? 6, what preconditions are required before test execution? 7, what percentage of SUT coverage do the tests represent? 8, do the tests currently execute without failure? And number 9, what should happen when regression tests take too long? Now let's go through each of them in detail. So the first one is frequency of test execution. Tests that are repeatedly performed, especially during regression testing, they are perfect for automation. Here is why. Let's say that you have certain tests that you run over and over again whenever you make changes to your software. These tests already exist and they check specific functionalities you are familiar with. Now, when you automate these tests, it means that you are using a tool or a program to perform these checks automatically rather than a human doing it manually every time. The benefit is that automation drastically cuts down the time it takes to run these tests. What used to take hours or days for a person to perform can be done in minutes or seconds by automation. So these tests that you are already doing frequently, when automated, saves time and it also guarantees reliable testing. The second one is test execution time. For this one, let's take an example of a relay race in which team members run portions of the race, passing a baton to the next runner. Each test you perform is like a runner passing a baton to the next. Now, some runners runs very fast, while others take more time. In testing, some tests take longer to complete manually, and they are like the slow runners in our race. So to make your testing relay faster, you focus on giving speed boost to these slow runners first by automating these tests. This allows them to run faster laps in the relay race. With these tests automated and sprinting through their laps faster, you can fit in more rounds of the relay race within the same time. As a result, you get more chances to check the software's quality. Ultimately, this strategy helps in spotting any issues earlier, and it provides more feedback on how the software is doing and reduces the risk of any issues when you finally deploy the changes. Number 3, functional overlap. Think about sorting out your wardrobe. Let's say that you have got quite a lot of clothes. When you're organizing, you realize that you have a few similar shirts in different drawers. Now, if you are automating tests, it's a bit like organizing your wardrobe. You are trying to make things more efficient. So instead of having multiple similar things scattered around, you would want to tidy up and group them together. It's like folding those similar shirts and putting them in the same drawer, making it easier to find what you need without wasting time searching in different places. Similarly, when automating tests, you are trying to avoid having the same task or function repeated in different tests. You are aiming to organize them neatly so that there is no unnecessary duplication. It's all about keeping things tidy and streamlined. Now, you have organized your wardrobe. This organization brings efficiency because when you need a specific shirt, you know exactly where to find it without searching through different places. It saves you time and effort. In the same way, when you organize your automated test by reducing overlap, it's like having a neat wardrobe. This means that when you are running tests, you spend less time on repetitive tasks or similar checks. So as you add more and more tests, this efficiency becomes very important. It's like having a well organized wardrobe that gets even handier as you keep adding more clothes. So finding what you need quickly without any unnecessary hassle. Okay, so we compared automating tests to organizing your wardrobe. Let's say that you are using specific type of hangers or shelves that allow you to easily reuse them for different clothes. These special hangers or shelves represent reusable components in your test. In addition to that, your wardrobe might also have a box where everyone in the house can share accessories like scarves or belts. Similarly, in automation, there are shared spaces which are called data repositories. These repositories store information that multiple tests can use, just like your shared accessories box in the wardrobe. So, when the tests are developed using automation, they take on a new structure. They rely on reusable components and share data repositories. This new structure makes the testing process more organized and efficient. It is quite usual to break down or divide larger manual tests into multiple smaller automated tests. When you are transitioning from doing any larger tasks manually to automating them, it's often beneficial to split these larger tasks into smaller, more manageable parts. Instead of one big test that covers everything, you might break it down into smaller, more specific tests, each focusing on testing one particular aspect or functionality. This approach makes the testing process more modular and easier to manage while providing more granular insights into each specific area being tested. Similarly, sometimes it makes sense to combine multiple smaller manual tests into a single larger automated test. This can increase efficiency, it can reduce duplication, and it can offer a more comprehensive assessment of the software's functionality. And lastly, when you want to switch from manual tests to automated ones, it's like planning a big change. So you would need to look at each test by itself to see how best to automate it. But you would also want to step back and look at all the tests together to figure out the smartest way to make this change happen smoothly. It's like looking at the details of each test and also thinking about the bigger picture. By doing this, you can come up with a very good plan to switch from doing this test manually to having them run automatically. Number 4, data sharing. Let's say that you are dealing with tests like checking how much vacation time an employee has or what courses they have taken for career growth. Now, often these tests use the same employee's info but check different things about that person. For example, in this scenario, employee ID and employee name will be the same. In the old manual way, every test might keep copying and pasting the same employee details over and over again. It's like writing down the same info repeatedly in different places, and that's a bit of a hassle. But with automated tests, you can do something smarter. Instead of copying that employee's info every time, you can store it in one place. It's like having a master file where you keep all the employee details together. So when each test needs that employee's info, they just go to that master file and grab it. It's like going to one place to get what you need instead of searching in lots of different spots. This way you avoid mistakes that might creep in when you copy the same info multiple times, and it makes things easier to manage. Number 5, test interdependency. Think of it like playing a video game where you have different levels. Sometimes to reach the next level, you need to complete a specific task or get a special item, right? So imagine you are playing and completing a level. This action gives you something new, like a special key. Now, the next levels might need that key to unlock new doors or do different tasks. In the game, that key you got earlier is like an order ID that you need for future levels. Similarly, when running tests, sometimes one test creates something new like an order ID. Other tests might need that specific order ID to check if the new order ID is displayed correctly, if changes can be made to it, or if it can be deleted. So in these tests, when something is created in one test that the other tests need to use later, it's like grabbing that special key in a game to unlock new areas. The system needs to be designed in a way that lets these different tests share and use that important info like the order ID created in one test for the others that come after. Number 6, test preconditions. Let's say that you are getting ready for a road trip. Before hitting the road, you need to make sure that your car has enough fuel, you have the right map for navigation, and your bags are packed. These are like the initial conditions before starting your journey. In testing, before running a test, you need to prepare things too. It's like making sure that your car is ready before your trip. So these preparations might involve choosing the right test data from a database or setting up specific values needed for the test. Now, here is the interesting part. Just like you would organize everything before a road trip to ensure a smooth journey, in testing you can automate these preparatory steps. It's like having a smart assistant who takes care of filling the gas, checking the map, and packing your bags for you. By automating these setup steps, it's like having a reliable assistant ensuring everything is set before starting the test journey. This makes sure that your tests run reliably and consistently every time, just like how a well-prepared road trip ensures a smoother travel experience. When converting manual tests, including regression tests, into automated ones, These initial conditions become a vital part of the automation process. It's like making sure your car is road trip ready before starting your journey. Similarly, these automated setups ensure that test runs smoothly without missing any important steps. Number 7, SUT coverage. Let's say that you are playing a video game and each level tests different abilities or challenges. Similarly, every test checks a specific part, like levels in a game, to make sure that they are working correctly. Then the next point is that to make sure the system works very well overall, test needs to be designed to cover a wide range of functions. It's like making sure that a car is reliable by checking not only the engine but also the brakes, lights, and more. Similarly, these tests are like checking all parts of the system to guarantee that it works smoothly. Then the third point is that we have tools which are available that keep an eye on how much of the system is tested by these automated tests. So let's say if you are cooking, it's like having a progress bar while cooking to see that how much of the recipe you have covered. Similarly, these tools track how much of the system is tested to determine how effective the tests are. Okay, so the next point is that when we repeatedly perform automated regression testing over time, by adding new tests, we can expect that these additional tests will examine and verify more parts or features of the system that haven't been previously checked. This gradual expansion of testing coverage helps ensure a more comprehensive examination of the system's functionality. Then next point is that in testing, measuring how much of the system is covered by test is like assessing the reliability of the software. So when we measure the coverage of test, we are essentially determining how much of the system functionalities and behaviors are being checked. This measurement helps us understand how valuable or effective these tests are in making sure that the system works as intended. It is important for quite a few reasons. By measuring the test coverage, we gain insights into how thoroughly the test examine different parts of the system. And it also helps us spot areas of the system that haven't been tested. So, and identifying these gaps guides in on where to focus additional testing and which minimize the potential risk. And this measurement also support decision-making processes, especially in determining if the system is ready for the release or further development or not. Number 8, executable test. Before you automate a test, you need to make sure that the test, when done manually, works perfectly. This makes sure that when the test is automated, it will function correctly without any errors or issues. Making sure that the manual test is accurate is like having a good starting point for turning it into an automated test. It is similar to having a solid base before building something on top of it. This helps to make sure that the automated test will work smoothly and effectively. Okay, so now the next point focuses on what could go wrong if the manual test doesn't work properly. So trying to automate a manual test that's already broken is like trying to fix a machine with a broken part, and it will not work well. It will result in an automated test that also doesn't function properly. This not only wastes time and effort, but it also doesn't give the expected results, making it unproductive. The last one, number 9, large regression test sets. Let's try to understand this with an example. Let's say that you are a software tester responsible for testing a large software application. The test suite for this software is quite extensive, so much that running all the tests in one go is not feasible overnight or during the weekend due to time constraints. Now, if you had multiple computers available, you could run different parts of the test simultaneously without a problem. However, in the case of complex systems like airplanes and space rockets, the testing environments are usually limited and highly valuable. These testing environments are rare and costly, which makes it impractical to execute all the tests at once. So, what is the solution? One possibility could be to divide the test suite into smaller sections and execute only a portion of the test at a time. It is like focusing on testing specific modules or functionalities of the software during different testing cycles until all parts of the software have been thoroughly tested. Now, how do you decide which part of the test suite to execute each time? You might prioritize based on the parts of the software that have undergone recent changes or updates. For instance, like if there were modifications in the user interface, you might prioritize tests related to that area. So, in summary, if you have lots of tests to run but not many resources, it is helpful to split the tests into smaller parts, then focus on testing the parts that have been recently changed. This way, you can do thorough testing over time despite limitations. Section 6.2 ends here. We will cover section 6.3 in our next session. Till then, take care and happy testing.